Alrighty. It looks like everything's good to go. How is everyone? Let me know if you can see and hear me okay. That would be great. Hope you're doing well. Thanks for joining us on this special first of the year. Happy 2025 to everyone out there. First of the year live stream broadcast for us here at the Geology Explained team, as it were. Let's see. Yep, J. Scott McLean says I'm 5x5, so excellent, as does Mandy Joe. Sweet. Great. We'll get started here in a few minutes, so thanks for joining me. Hope you can see and hear me okay. Thanks for all of you for spending time with me here today. I'm excited to get back to things. It's been a whirlwind of a holiday break and some traveling and big events happening also around the world that caught my interest, such as the Ethiopia situation we're going to talk about. Kilauea erupted right before Christmas and has on and off been erupting since then, along with some interesting things going on in Iceland. So it's fun to have everyone here. Hello to everyone out there. I probably won't be able to get through all the shout outs here, but thanks to everyone for joining. Of course, we have Amanda Joe and Susan Helmer as our moderators today, so I want to give them a very warm thank you for continuing to serve great as our moderators, keeping things organized, keeping me from just being a scatterbrain, which is easy to accomplish. So fun stuff. And Laura, awesome. Thanks for your donation to the channel. That's great. Heidi, hello. Keaton's out in Topaz Mountain. Probably chilly out there. I'll try to do a couple shout outs. We only have a few minutes here. If I miss you, I apologize. Wes is in England where it's currently -4 Celsius. Yeah, chilly here too. Not quite that cold. But it is the clutches of winter, I suppose, if you're in the northern hemisphere. All you southern hemisphere people are chuckling and probably laughing a little bit at all of us suffering through the cold weather if you're at a high latitude. Frank in Berlin, Jean Patrick in Munich, Hillary is in Cambridgeshire, England. Gary's in Ridgecrest. Hope you're doing well there. Charlotte's in the Snowy Peak District. William, Pleasant Valley, New York. Keaton says it's not too chilly, just no snow, just got a bit of red burl. Nice, excellent work. So he's out there in the field doing a little rock hounding for some crystals out at Topaz Mountain in the West Desert of Utah. Griette says hello to everyone from Belgium. Klaus from the Netherlands. Macabet from a tectonically dead and boring zone in northwestern Arizona. Arizona's fascinating. I mean, there's some interesting things going on there. I went to NAU, so I have a very soft spot in my heart for Arizona geology. Hans Heinrich from the Denmark. It's chilly there as well, it looks like. Viux from Latvia. Thanks for joining us. GLF Video from Idaho. Zhao from Portugal. Julie from snowy Michigan. Gary from windy Southern California. Yeah, we may talk a little bit about just the, I know it's a big news item, especially in the US right now. We may, during the question and answer period, talk a bit about sort of the conditions that led to the fierce winds that fueled these, that really got these wildfires going out of control in the Los Angeles area. Elaine, hope you're doing well in Tucson. Tess from a snowy Sweden. Great. It's great to see you all back here. I've missed you. We had a fun, though, wrap up to the 2024 year with our fun live stream there just before Christmas. We gave away some prizes. I think those got to most people. I've gotten several emails from folks that were really happy with their sweatshirts or hoodies or t-shirts or whatever it is that they ordered. So awesome. Okay, it's the top of the hour. I'm just going to go ahead and get started here. Well, thanks for joining me, one and all. My name is Shawn Willsey. I'm a geology professor here at a college in Idaho. Welcome to this live stream broadcast. We're going to cover several things today, but I appreciate you taking your time coming in here. Happy 2025 to you all. I hope you're well. It's going to be a great year. I feel like each year with our channel and our community here, we've managed to do more things and engage with more people, and it just seems to be growing, and I'm still able to keep my head slightly above water. So I think all in all, everything's going great. So happy 2025 to everyone. I've got a general outline here, kind of just generic outline of what we'll accomplish today. So I've got a few announcements right off the bat that we'll get to. We'll talk about the situation in Ethiopia as best I can. Information from that part of the world is hard to get, or at least it's been challenging for me, but I've been able to get a few things, and I've had some helpers along the way, and so we can discuss that a bit. We'll talk about Iceland. Actually, we're going to talk about two different areas in Iceland. And then we'll come to you for any questions that you have, kind of open format, hopefully mainly focused on the topics we discuss here, but potentially able to broaden it to some other topics. If you're following along in the live chat, you can submit questions, just kind of follow the instructions they have there. Mandy, Joe, and Susan are there to make sure everyone stays positive and kind of on task, I suppose, and everyone plays nice, but you guys always do a good job of that anyway. So awesome. Did I say the 10th or the wrong date? It is January 10th, right? Yes, I should know that. My son's birthday's in 2 days. Yeah, so there's a huge typo right there, right off the bat. So this should say January 10th. This is not a good start to the new year. Okay, so scribble out. I did get the right day. I did get the right month. And I did get the right time. So I'm gonna assume that 3 out of 4 is a pretty good start to the year. But yeah, it is January 10th. So sorry about the typo there. But first things first, our first big announcement is that we want to wish one of our great viewers, Sandrine in France, a very happy birthday. Today's her birthday, January 10th. And she sent me a picture of herself where she's wearing the prize that she won from the live stream giveaway. So this is some of our new merch that's available. And I've heard really good things from all the people that have received that. So thanks so much, Sandrine, for sending that picture yourself. You look fabulous. You look even better in that great hoodie. And just as a quick aside, I'll let people know again that if they're interested in ordering anything, you can go to my website, willseygeology.com, which is manned by the awesome and amazing Amanda Jo. If you go to merchandise here, then you click here where it says to order, and then that takes you to the online store, and we have different types of shirts. So you can go in here and look at the shirts if you want to, different colors, sizes, women's cuts. Anyway, you can just scroll through the list, just reminding you that that stuff's available, and that's been making its way to people over the last few weeks, and I've really heard good things about the quality. I've been happy with I'm wearing a shirt right now with the little kind of hoodoo on it. The quality's good. The hoodies are very comfortable. I even got some of the stickers, and the stickers are really nice too. Here's a sticker on my water bottle right there. You can see that little sticker. There we go, right there, the volcano. Yeah, so we've just heard good feedback from folks. So if you're interested and you want to represent, there's an opportunity for you to do that. And we appreciate folks for doing that. Other ways you can support the channel if you're so inclined. First of all, there's no obligation to be part of our community. Just showing up and watching the videos and engaging with us is all you need to do. But if you do want to donate, there are ways to do that. If you go to the YouTube page, there's a couple of options here. There's a PayPal link. There's this Buy Me a Coffee link there. And then you can also, under any video you go to, so for example, if I go to a video here, and let's say just kind of start one, you can go down, hit the 3 little buttons here, and then there's one that says thanks, and that gives you an opportunity to donate that way. Again, not at all required, just an option for those that feel compelled to. So awesome. So Sandrine, you look really great there. Thanks for sending a picture yourself, and I hope you have a great birthday, because today's the 10th and it's your birthday. So good news. Okay, let's see. So one quick little update on the graphics. I have a friend of mine, a student, actually, former student, who I think I showed you guys this last time, is working on a logo or some sort of graphic for the random road cuts. I think what I'd like to do with this is have this pop up at the beginning of a random road cut video just for a few seconds. And then what I might have him do is turn this into something maybe a little bit more simplified that will go on like shirts and hoodies and hats and stuff. But anyway, we did get some feedback from you about this graphic. Several people said, hey, it's great that you got a female in there, but since the random road cut thing is kind of you looking at the road cut, meaning me, maybe it should be someone that kind of looks like you. So he's retooled the graphic, and this is what we have so far. So we've changed the kind of outline here to more of a circle, a little bit of shading in there, put some blue sky up above. And so that's kind of where we're at now. So if you like that, let me know. And then I think what we'll do is simplify it a little bit for the merchandise. Probably take the person out, make the rocks a little bit simpler, leave the road in there, so it's just more of a simple, clean look on the logo there. So that's kind of where we're at with the random road cut thing if you're interested. So look for that maybe soon, and once we get the simplified version, that can pop up on the store with the merchandise pretty easily. But I do have one more random road cut in the hopper. I'll try to get that out in the next week or so for the folks that enjoy those. So yeah, so it's been kind of fun to work with him on things like that. And then my last announcement here before we get down to the nitty-gritty, friends, is I showed you this last time during our live stream right before the break, but there's a few little tweaks here. So I haven't had time yet because it's been a whirlwind of a holiday season, as I'm sure it has been for you. And now I'm staring down the barrel of the semester starting pretty soon. The only real tweak here is I am going to do field trips around Twin Falls on the 11th and 12th, but I did have one person say, hey, could you go somewhere different? I think what I want to do is keep repeating some of these field trips for folks who aren't able to come to them when they're initially launched. But I do have some other ideas of field trips in this area of places people have not been to, at least not with me. And so I'm going to try to get that figured out soon. It may be, again, so the April field trip, not sure where it's going to be. It's just going to be based here in Twin Falls, and it could be a repeat of trips I've done in the past, or it might be some new locations, still figuring that out. And then the bigger piece of news, I suppose, here is many of you are also fans and follow Nick Zentner, who also runs a fantastic geology education YouTube channel. And last year, he and I were trying to get together in the summer in central Idaho and have maybe viewers show up and be able to meet with them. And he and I were each going to give like a little spiel up there. And what happened was we had just a terrible wildfire situation going on up near Stanley, near the Sawtooth Mountains, and we had to completely postpone that event during the summer. Since then, Nick's had some issues with his wife's health that have been pretty serious, but those appear to be mostly resolved. And so he texted me yesterday and said that he's a go for doing something in June. I think the day with him, it might actually be the 28th. So don't put these on your calendar in ink just yet, but definitely that weekend and around that time frame is when he and I are looking to get together somewhere in central Idaho and spend some time together looking at rocks, that sort of thing. And then we'll definitely allow a day or so for viewers to meet with us too. And then I might run my own field trips on the side. I don't want to tie him up for a bunch of days. But maybe he wants to come with me. I don't know. I'll see what he wants to do. And we might do a couple other days up there looking at some of the cool geology in around Stanley in the Redfish Lake area, Sawtooth, over towards Chalice. There's a lot of things going on. So yeah, the 28th is a Saturday. That's the day I think Nick and I would be together for sure. But I need to map out a time frame and a plan with him. And so just look for an update on that. This is sort of preliminary, but that's more or less the window of time that we're looking to do something with. And then I'll get some other field trips out later in the fall, but my head's not that far down the way. Just keep checking the channel. Once I get a field trip set up for sure, then Amanda Joe runs with it and it gets set up on the website and you can sign up and do all that there. So, okay, good stuff. So that is a little bit of an update on announcements. Since I saw you last, my wife and I took our anniversary trip just after Christmas. We've been married 30 years, and we decided to go somewhere new. We haven't been. We both like cross-country skiing, so we decided we would go back east, and we went to Vermont. We went to Stowe, Vermont. The funny part of the story is that we landed in Burlington, we drove to Stowe, we got up the next morning, we put on our skis and we skied around on some trails, and it was fantastic. And then later that day and into the evening, it got warm, it started to rain, it rained all through the night, and by the next day the snow was completely gone. But we still did some fun little hikes and waterfalls and things. And then later on that trip, we went up to Montreal for New Year's Eve and to check out that area, which we'd never visited before. So that's kind of what I've been up to so far. And I could update you on more things going on here, but I think we'll do that later. Let's just get right to some of the things going on around the world. Let's start with this bit of action that's been happening in Ethiopia. So I've had several people send me messages as these things were taking place, asking me for my take on it. And I, of course, was interested in trying to dig into it as much as I could. But one of the I guess, frustrations I had was there was a limit in terms of the scientific data that I could find that was accessible. Recognize we're dealing with, a different section of the world. I think we're a little bit spoiled with the Icelandic scientific community and the USGS and some other countries. And so when we get to other parts of the world where maybe those resources aren't as readily available, it can seem a little bit frustrating. But nonetheless, I have some things to share with you as best I can. So just quick step back, here is Africa. This is the area that we're looking at here, which is part of Ethiopia. And as many of you know, this section of Africa is a continental rift. It is a section of Africa between two different plates that is a divergent boundary. Basically, it's going to take a while, millions of years, but eventually this section of Africa, if the process continues, will completely rift away from mainland Africa. The sea will flood in through this area here, and this chunk of crust here, or land, will be a separate large island off the coast of Africa. But the process is still ongoing, and the earthquakes and all the activity that's taken place recently is all part of that process. This is called the East African Rift. So it's here in Ethiopia. This area here is sometimes called the Afar Triangle. So it's really, there's a triple junction right here. You have the Red Sea, this is the Gulf of Aden, and then the other arm of this triple junction comes onto the continent. So a little different setting here, where this is a continental rift and the plates that are breaking up are still on land, whereas these two divergent boundaries here, the Red Sea and the Gulf of Aden, are in the ocean. These are more evolved, more developed, more mature divergent plate boundaries. But nonetheless, this is the area in question, and you can see from the USGS site here, these are the earthquakes that have been taking place. I've got this for the past month, so this is the past 30 days or so. Most of these have occurred from today back to, I think, the December, maybe late December, so like the 22nd, 23rd, somewhere in there. And then let's kind of zoom in a little bit here. Actually, let me go to Google Earth and we'll come back to these quakes. I just want to orient you a little bit more on the lay of the land and show you some of the topography. Because Google Earth is a wonderful tool. And as we learn about a place that maybe is producing earthquakes or having any sort of unrest or whatever, it's a great tool to just kind of see what's already gone on there. So here you can see a little bit better. With the colors here, you can see that there's a valley here, so the lower topography is right here, and then where you see it kind of turning green, this is higher topography. So this is the area in question. The plate boundary runs more or less through this valley, but just like we've seen in Iceland, it's not like a clean one line, one structure plate boundary. It's actually a series of structures. It's a segmented plate boundary, so it's not all one through-going system. And the two volcanic areas that will be important as we kind of pursue learning about this area is this volcano here called Mount Fentale. Hopefully I'm pronouncing that right. So you can see actually the crater there. This is a pretty good sized volcano that's been sitting there for quite some time. And then there's another one here, a little less well defined, but this is called either Dauphin or Dauphin. I've seen this spelled with an A and with an E in both ways. And real quick, before I get going too far, I want to give a quick shout out to some folks who've really helped me find some resources on this Ethiopia situation, and that would be Amanda Joe, who sent me a tremendous amount of information, so a big thank you to her. But also viewer Eric Fielding and Oliver Ziegler sent me emails with some information that was helpful. So we have volcanoes here in this rift, so as the plates are moving apart, that's thinning the Earth's crust. As you thin the crust, that triggers what we call decompression melting, and so that generates magma. So that's why we see volcanoes in this region, just like in Iceland. Iceland's also over a hot spot, but even if Iceland was just a divergent boundary, it would have volcanic activity at any rate. And then if you zoom in here a little bit closer and, ignore the volcanoes for a little bit, you can see some obvious structural trends here. You can see cracks or sort of a textural grain on the land that seems to run in a northeast southwest direction. In fact, the trajectory of all these structures is eerily similar to what we see on the Reykjanes Peninsula. If you think about the row of craters there at Sunnukur, or the intrusion that formed there, so that we have faults on either side. So some of these are actually faults that are dropping the interior side down and then raising the flanks up. And then just to kind of show you the topography in a little bit more detail, what I've done here is drawn a cross-section line right through the volcano, this one volcano, Mount Fentale. So you can see hopefully this red line coming across here. And let me show you what this looks like in terms of topography, because unless you're, and actually you can't even see this because my stupid face covers it, but if you get way down here, you can actually read the elevations as I move my cursor around. And so there's actually quite a bit of variable topography. There's topography that goes up over 10,000 feet in some areas here. And then out here in the middle of the rift, it's around 3,000 feet. So it's, whatever that is in meters. So let me show you what this line looks like in cross-section. If we're going to look at this cross-section from this flank here, the western flank of the East African Rift, over here to the eastern side, right through the volcano. And when you use Google Earth and draw a line, you can then select that line and then click Show Elevation Profile. So down here, what you can see is what this line looks like. Let me actually swing this around so it matches up nicely. There you go. So there's the cross-section line. We can almost get it to line up perfectly. There we go. It's pretty good. So coming across this area from northwest to southeast, you can see the high topography here. And I do have this in feet, so I apologize for all the folks that enjoy metric, which also includes me, but I just had it set to feet. Well over 8,000 feet here on the flank. And then you can see it dropping down. Here's the volcano. So right at the center of the rift, where the crust is presumably much thinner, the magma that's been generated has come up and constructed the volcano. So that's Mount Fentale there, and you can actually see the interior crater there, or the big notch in this topographic profile. Then the topography drops off, and then as we head to the southeast, it rises back up to about 8,000 feet on this side. So it gives you that nice sort of bowl-shaped view. But in reality, what it is, and the topography the cross-section shows us a little bit as well, is there's a series of faults that are dropping one side down. So I wanted to give you a little bit of perspective there, showing you what the topography of the East African Rift looks like here using Google Earth. So hopefully that was helpful. I'll go ahead and maybe pull myself a little bigger there and just cover that up. Anyway, so a couple other things here, and then we'll get to the recent events. So if you zoom in here, you can see there's a lake, but then there's also obvious evidence of volcanic activity. Here's a big lava field here. I have no idea how old this is, but it fairly recent, within the last few thousand years. We can look at some of the individual vents, and if you've watched my 101 series, or you've educated yourself on volcano types, you can identify these structures. That's a nice looking little cinder cone there. With this flow field around it, actually right next to a little town apparently. But you can start to pick out these volcanic features on the landscape. Here's another little cinder cone, another one over here. So a lot of the basaltic features in the lava flow fields pop out pretty easily if you're familiar with them. But this also has eruptions of rhyolite on occasion, which is a much more explosive and dangerous type of magma. And definitely whatever types of eruptions have happened here have been much more explosive. To produce a crater of that size and diameter, you need much more explosive eruptions. So as that magma is coming up through this continental crust, this thick crust in Africa, in some instances it assimilates some of that crust, which is high in quartz. It's granitic in composition. It changes the composition of the magma, and so we get these more rhyolitic magma types that fuel these more explosive eruptions over time. So this is, I don't know the history of this volcano, but you can see it's got a much more formidable and explosive type of characteristic to it. Okay, so you can see, and it looks like the last eruption around Mount Fentale, according to my notes here, was in 1840. And so we do have some record of this area having, you know, sizable eruptions in recent history, in human history for sure. And that's kind of what we're dealing with right now. And so going back to the data and what's been happening there over the past few weeks or so, is we had an earthquake swarm that began. Now there was an initial swarm that began that was kind of off my radar. I think I do remember hearing about it, but I definitely didn't make a video about it, and I didn't really dive into it. I just kind of made a mental note and went about my way. But there was a swarm, not the one you're seeing here, but there was a swarm in late September to early November of this past year, 2024, magnitude 4 to 5 earthquakes, and that's being followed by this second swarm. So here's this second swarm of quakes, mainly 4 to 5. Now recognize our data set here, right? Like, where are we getting this information? This is the USGS. So we're only really capturing the earthquakes that are big enough for our seismic system to record. So you might be like, well, where's all the 3s and 2s and the little negative earthquakes and the tiny ones? Well, it's not in our data set. So because this is a USGS data set, we can only detect these larger quakes and be able to accurately plot them. The smaller quakes, that seismic energy is not traveling all the way to the US seismometers. And so this is a very biased data set is what you're looking at. But nonetheless, it does give us a view of some of these bigger earthquakes, and I think the biggest one in here was a 5.7. I'm not sure which one it is, but I can pull it up right here. So the biggest one of the lot was a 5.7. These all began in late December, so just around Christmas time, and there's about 65 of them so far. Let's see how many we have on here. Yeah, 62. So 62. Oh, now there's 71. Just depends on how you zoom in. So yeah, with this view right here, there's 71 quakes that have happened in the past month that are over magnitude 4.5. If we put the smaller ones in there, we just don't get that many because, again, of the limited nature of the data there. So, but here is one of the quakes, and notice the beach ball here. This is a normal fault. So this beach ball tells us that the fault that produced this earthquake, this 5.7, shallow depths too. Remember, these are very shallow earthquakes. This was a northeast southwest trending or striking fault, and because it has this white area in the middle here, that makes it a normal fault. So you can see that, and notice that orientation is parallel to the plate boundary. The plate boundary runs through here at a northeast southwest orientation, and the beach balls show that that's the type of faulting we see there. Another view of the earthquakes here from a different data set here, but just a similar sort of thing where you can see all the little purple dots here superimposed on the topography there. So this is all data that's accessible here. And then let's see, what else do I have here? And then there was, so we had the earthquakes, which were large enough that they caused damage to homes. It was collapses. Obviously, the people were quite panicked. These are, not necessarily large earthquakes, but big enough to substantially shake structures, get people very much on edge, and so that was the first bit of scientific data that was alarming. And then there was the ground deformation, and so this is a pass with the Sentinel-1 satellite and INSAR interferogram that shows, so they passed over the area on the 17th of December, and then they made another pass on the 29th. So in 12 days, this is how much the ground had moved in that 12 days time. So the earthquakes in and of themselves might just have been faulting, but when this pattern emerged, it became much more obvious that the earthquakes were related to an intrusion of magma. So an intrusion of magma had moved up into the rocks, pushed the rocks apart, moved the ground up, and the interferogram here shows that. It shows these bands here, and if you count these bands, this is Eric told me here, what did I write down? This is 2.8 centimeters. So each fringe or each color band you see is an uplift of 2.8 centimeters. So if you start counting these, which is hard to do because they get really small, I think I counted 13 or so. So that gives you about 36 centimeters, but let's round it up to 40 centimeters or so of total uplift just in that 12-day window. So a pretty substantial event. So we have the earthquakes that preceded or went along with the dike being formed. We have the interferogram, which is the ground deformation, which shows us how much the ground uplifted. And also you can see the orientation of the dike, sort of this, again, northeast, southwest trend here. There's the mountain Fental, that's the southern volcano. There's the northern volcano there in that lake at the southern end. And then if you start looking at the scale here, this is a dike that's anywhere from, depending on you measure it here, like 30 to 40 kilometers in length. So this is a substantially large body. It's probably not very wide. It's probably only 1 meter to 2 meters wide, which is pretty typical of these things. But when you factor in the length and the width and sort of the depth that it's going down into, this is a large batch of magma that formed in the system. So these were the things that were leading up to the next event. And so the next event was the I think on January 3rd, there was these explosions out of the ground of steam and mud and rock. So you can see sort of these little mud pots here and things being shot out of the ground. So it begs the question, and it's a good one. Is this an eruption, right? Is this truly a volcanic eruption that we're seeing here, or is it something else? And I think it just depends on, maybe your background and what you're used to seeing. No lava was emitted, no ash was emitted. It was mainly mud, water, rock that came out of the ground. And so I think my take on it is that it seems to be like a hydrothermal event, kind of like what we saw in Yellowstone. You might have seen my video from this summer in Yellowstone where we had explosions of mud, water, and rock out of the ground caused by gases, essentially, but not necessarily the volcanic lava and the ash per se. So this, in conjunction with the earthquakes, which were quite intense, and some of the collapse of the buildings, and the interferogram, all this prompted the local officials to evacuate up to like 80,000 people. So there was a mass evacuation. This one's here a little bit older, but I think it was up to 80,000 or so people that were evacuated. Might have been more like 60, but 60 to 80,000. So again, the numbers are a little bit off there. So what do we make of this whole thing? It's definitely something that warrants continual monitoring. I don't know much about Ethiopia's system in terms of their seismic network and volcano monitoring resources that they have available. It's definitely much more limited than in the U.S. or Iceland or other countries. I suppose my big take is that now that people are evacuated, the clock is ticking because you can't keep people evacuated indefinitely. So either this escalates into a bigger event and then people are evacuated and they're safe, or you run the real risk in the difficult decision of letting people come back if you think it's quote unquote safe, but then possibly having things escalate quite quickly. So I'm not really sure in terms of, it's a good chance that this was just an intrusion and it could stay that way and everything could subside, or this could escalate. But what was really striking to me, if you think about the sequence of events here, did anyone feel a little deja vu moment here? We had earthquakes, magnitude 4 and 5 earthquakes, people alarmed, significantly large earthquakes that people are feeling those quakes, and it's causing some level of distress or panic, right? We had the uplift of the ground in a pretty short period of time. We had evacuation of people. And then, heck, we even have the orientation of this dike that intrudes is northeast-southwest. And the whole thing just is very similar to what happened in Iceland around Grindavik in November of 2023, just a little over a year ago. So it's very similar to what we saw there. And it could end up culminating in an eruption. Remember, in Iceland, we didn't have an eruption initially, even though on November 10th, I would have put all my chips on the table and told you that an eruption was going to happen. Didn't pan out immediately. It took another month or so of continual unrest and magma accumulation to actually trigger that eruptive event. So really similar situation going on there. And of course, we hope that people are safe and that there's no danger to the folks there. But it'll be interesting to see how this plays out. There still is seismic unrest as of us talking about this and recording this video, but right now, at least, there hasn't been an actual eruption of magma or ash. It's just it's been a disturbance in the hydrothermal system. There's been a serious amount of heat. What I'd like to know about that video we watched is are we seeing volcanic gases coming out, or is that just hot water, or are there actually volcanic gases along with that? Because that would, I think, change the equation a little bit in terms of how we treat that. So that's all I have for you on Ethiopia. I probably didn't answer all of your questions that you might have. Of course, you can put those in the chat, and I'll try to answer those as best I can. Just please realize that I did my best to try to piece the information together, but we're talking about a part of the world where information, especially scientific information like that, is not readily obtained, at least through the methods I tried to use there. Okay, so that is what's been going on in Ethiopia. So likely we'll see more. I would assume we might see some more news coming out of that part of the world in the days and weeks and months to come. Now let's switch over to what's been going on in Iceland. So let's head up to the North Atlantic and do an update. And we'll start with our old familiar stomping grounds here on the Reykjanes Peninsula, but then we'll head to a little bit different area of Iceland. So we'll start here as we have done before. And let me pull up my information on Iceland. Here we go. So we have a new Met Office update from this past Tuesday. Pretty short, but basically uplift continues. And the uplift, using the uplift as a proxy for the total amount of magma in the system, estimating the amount of magma in the system, which they have is about 12 to 15 million cubic meters. Using those numbers, we could reach that threshold. We could reach that the amount of magma needed to produce an eruption. That could happen by the end of the month. Not for sure, but that's when we would enter the window. So by the end of this month, January, there may be enough magma in the system on the Reykjanes Peninsula to produce an eruption. Doesn't mean it'll happen by the end of the month. It could spill into February. It could even go further into March. We'll just have to see how things go. Earthquakes have been pretty low, and that's kind of the extent of this very brief update here. They do have a nice graph here that just shows our favorite station, Svartsengi, and this goes all the way back to a year ago. So you can see each one of these red lines here is one of the eruptions that took place. So here's December 18th, January 14th, February 8th. The blue line here was an intrusion, as was this one here on November 10th. This was the March 16th. Now I got to try to keep all these dates in my head. May 29th, August 22nd, and shoot, what was this last one? November 20th, I think, was this one here. But you can see northeast plots, and then this last plot here is our up and down data. So you can see the amount of uplift. The eruption occurs, drops back down, eruption. And you can see sort of that stair step. Notice that the steepness of each one of these lines has become less steep over time. So we had faster rates of magma accumulation and influx into the system. That seems to have slowed down. The time between eruptions has lengthened to some degree. And so now we're out here at this green dot, more or less out here currently in January. And so it seems like it's going to take a couple more weeks getting us to the end of the month before we get to this threshold here. So it'll be interesting. I haven't received anything from our good friend Bruce Garner to see what his, he does a good job of kind of taking the data, running some statistical analysis and kind of extrapolating that and seeing when that window might actually occur. But the Met Office is saying perhaps as soon as the end of this month. So we'll just have to see. In terms of location of where we would see it, I would put it, you know, right at where we've seen all these things take place in the past, and so I would expect that this eruption would be very similar to the ones we've seen in the past, you know, in terms of, whoops, that's not what I wanted. I need to add, I'm missing some of my data here, long story, but anyway, so the main area here, just to the east of the power plant between the two hills here, I think I have my hills, there we go. It's between Silingerfeld and Stora Stogfeld. This is the area we would expect to have the eruption because that's where we've seen the most action in the past, but could be further south. Hopefully that's not the case. Could be a little bit further to the northeast. That might be better for the power plant for sure. And so that's what we're looking at right now. So that's a little bit on the Met Office's update. If we look at the latest just sort of simple trend here, from the GPS at Svartsengi, here's everything leading up to the November 20th eruption, drops back down, and this is our uplift that's been going on since. And it is, you know, it's not a perfect straight line. You can fit a straight line to there, but you can see there's periods where it's a little bit stair step, I guess, I suppose. So there's periods where it's flat or flat-ish, and then it ramps up a little bit more, and then it ramps up a little bit more. So you know, that may just be the influx of magma not coming in at a steady rate. It could also be, you know, the storage system maybe needing to, you know, the magma having to push through little constrictions or something in the storage system. I don't think that's the case because that would probably be signaled by earthquake activity, which we really haven't seen. So this is most likely related to just a pulsing or a inconsistent influx of magma into the subsurface that's sort of driving this little bit of a waviness to the uplift data here. So there's our uplift data. If we flip over to earthquakes, just for the past 24 hours, it looks like we have maybe one. This one's a little bit over near Fagerdalsfjord, but one 0.08 earthquake, so basically no earthquakes happening here. All the usual kind of suspects we typically see down near the tip of the peninsula near Elde, a few over in the Krishevik system here, and then if we zoom out, we're going to come back to these earthquakes up here. In fact, if we switch over to the last week or so, we get a lot more earthquakes showing up, and again we'll start with the area north of Grindavik. You can just see looks like there's 4 whole earthquakes that have happened in the area in the last week, so pretty sparse and very small earthquakes at that. A few around Fagerdalsfjord, scattered quakes around the Krishevik area, typical quakes we often see out offshore, but then there's a bigger cluster north of Reykjavik up here, and that's what I'm going to talk about here in a second after we finish up talking about the Reykjanes area. Okay, well I guess I am finished with that area there. So that's kind of a summary of what's been going on the Reykjanes. This is the area we've come to know and love and really watch closely a little bit over a year now. But there's another area that's become of interest in the last, I guess, few months, and I've been kind of watching it, but like I just wasn't quite sure like how much attention to give it. But I think it's had enough seismic activity over enough time that we should look at this a little bit. And these are some new Icelandic terms that I've got to try to pronounce, and the Met Office actually did a update on this area just yesterday, January 9th, and so here is the latest Met Office update about this area. So there's a lake there called Griotarvat, and I think that's how you pronounce this here. And the system, the volcanic system here, Here's the word for that, and that is Leosofjalt. Leosofjalt, I think is how you pronounce that. So you can see turmoil on the 2nd, continued seismic activity at great depths, but no signs of deformation according to GPS. And what we think is going on here, according to the Met Office, is a magma intrusion, but it's very deep. And so probably not. I think the big takeaway and the bottom line with this, as we look at this, before we get too excited that, oh boy, we're gonna have two webcams to watch two Iceland volcanoes erupting maybe at the same time. So before you get those double monitors up in your living room, I think the bottom line here is that it's not likely to produce an eruption anytime soon, but it is probably another place to monitor. There's definitely more important volcanoes to watch in Iceland than what we see here. These are deep earthquakes. Anyway, so let me just get to some of the things they have here. So yeah, seismic activity, but nothing big, nothing in the 4 to 5 range. These have all been kind of small, 1s and 2s at the most. You know, not a swarm of earthquakes like 100 in a day. It's been lower than that. But still, the conclusion of the Met Office is that it's probably related to magma moving at depth. And these earthquakes have been deeper. They've been about 15 kilometers down, which is deep for Iceland. That's shallow in most places, but deep for Iceland. Yeah, so while seismic activity continues, more earthquakes up to magnitude 3 can be expected, but it's unlikely that earthquakes larger than 4 can occur at this depth. So it's hard to generate that much seismic energy and the stress conditions, with the rocks being probably a little bit warmer at that depth. So we're not expecting like a magnitude 6 at that depth to occur. But still pretty interesting. And so I thought it'd be worthwhile having digested the last thing here on the Met Office. So in light of increased activity and indications of magma intrusion at depth, the Met Office has raised the monitoring level at Leosofjalt. A new monitoring plan is being developed. So basically what I would expect them to do is get up there with some instrumentation, put in some more GPS, maybe some more seismograph stations. We can't really use the interferograms there because the area is snow covered. Yeah, right here, INSAR measurements are of limited use at this time of the year because the area is heavily snowbound, which hinders the use of INSAR. So remember, INSAR uses the distance from the satellite to the ground. It takes that measurements, then it comes around, a week or 2 later and does the same thing. But if you have snow on the ground and the snow accumulates or the snow melts, that will make the ground look like it's moving up and down, which is the wrong kind of signal. So the INSAR is not going to be helpful, but the GPS would be. In early November last year, they did add a GPS station, but they've not measured any deformation there. But it says it does not rule out the possibility of magma being present at great depths. So you'd probably need to get that magma closer to the surface in order to generate the ground deformation signal that we would see with a GPS station. So a little bit there, but I thought it would be fun to look at where this is taking place. So let me get you here first. So here's our favorite area here, down near Grindavik. Here's the capital, Reykjavik here. And of course, you can see with these sort of the topography here, you can see where the volcanoes go, right, and their orientation. So you can see this northeast-southwest trend. You could trace that over to the big central volcanoes like Katla or Hekla out here. But the area we're actually going to is more or less due north of Reykjavik. So we have this town here, Borgarnes. And then I've actually driven this road too, and it's really this region right here. It's part of this peninsula. This is the Snæfellsnes Peninsula. Out here there is a stratovolcano capped by a glacier. And on the peninsula there are other volcanoes of various ages. And so what's interesting about this region, let me switch back over and I'll come back to this maybe, is that it's not where we would expect there to be volcanoes. The plate boundaries over here, it sort of splits into 2 arms, comes through here, then it runs up through the north, through Askja, and Krafla out here in this area. So it's not anywhere near the plate boundary. The hot spot's over here, so it's not near that. So it sort of begs the question, like, what are we doing with volcanoes over here? And if we go to a volcanic map of Iceland, you can see the Reykjanes Peninsula here. you know, coming up through the central portion of Iceland. There's this branch here from the Isle of Heimaey and the Vestman Islands over to Katla and Hekla, and then coming up through these volcanoes here. But this is the area in question. So if, you know, with the great irony here is, you know, if we're gonna put chips on the table in terms of like which volcanoes are going to erupt in 2025 and which ones should we really watch, most of my chips would be in this blob in here in the central part of Iceland, from the Reykjanes Ridge all the way through this area. You know, if you gave me 100 chips, I would probably put all of them. Maybe I'd save one for this little volcanic belt, the Snæfellsnes volcanic belt. And yet this is the one that's active right now, or this is the one that's showing some signs of potentially being active. So pretty interesting that it's a bit of an outlier in the volcanic systems of Iceland, and yet it's the one that's producing these quakes right now, that's causing, I wouldn't say alarm or even like concern, it just merits some attention, I suppose. Here's a little closer look at the system. So here, let me kind of orient you here. Let's go back to Google Earth. So we're going to zoom in. We're going to ignore the one out on the edge there because the quakes are taking place. There's a town here called Bifrost, or it looks like Bifrost. And actually, if you zoom in here, and I've driven right along, this is right along the ring road, Highway 1. There's a fantastic little set of cinder cones right there off the road. You can pull in here and park and hike up to the top and look around. So you can see that there's fairly young volcanoes here, and the earthquakes are happening mainly in this region. Right over in here is where we're seeing a lot of the earthquake swarm happening, right on these lakes. And there's some interesting things going on. I was actually looking at this earlier, but look at the ground pattern here. If we zoom in close, what do you see? Actually, there's two things I'd have you look at. Look at sort of the pattern of the ground, which is mainly just, you know, moss covering a little, you know, the rock. The rock's very close to the surface. Also look at the streams. I'd have you especially look at this stream system here. Look at some of the crazy things it does. There's a right angle turn here, a nearly right angle turn here. Then it comes over. There's kind of a long skinny lake. Right angle turn here, another right angle turn, another right angle turn. If you look at it, you'll see that there's sort of these sets of what we would call orthogonal fractures. There's a set of fractures that run northeast, southwest, and then a secondary set that runs more or less perpendicular to that across here. And it's an interesting area. I don't know. I'm assuming it's basalt, but maybe it's like hyaloclastite or another rock type there. I don't know. It might be on my bucket list of places just to go check out next time I'm over there. Anyway, and here's another stream with kind of these crazy. So the streams are taking advantage of these fracture pathways, and it leads to these very interesting geometries in the stream pathways. There's a little weird 90-degree jog there. Anyway, this is the area where the streams, or excuse me, where the earthquakes are taking place. You know, and again, you can come in here and see, you know, there's some pretty red scoria right there, some cinders from an eruption. So you can find evidence that this area has had eruptions in the not so distant past. If we come over here, it looks like there's a big lava field out here. And yeah, here's the cones that produce these flows and some very red, vibrantly red scoria, like pieces of lava that were thrown out of the ground. And there's another little crater right there. So what's interesting about this system is that it hasn't had an eruption in quite a while. I think it's been 1,000 years since this volcanic system has had an eruption, and it's sort of broken up into three segments. There's the big stratovolcano at the end. I can't remember the name of this segment here, but there's a secondary volcanic segment here, and then this is the one of interest kind of coming across to here. This is the one that is showing a little bit of signs of potentially doing something. So we'll just have to see. Real quick, why are we seeing this here? Well, let's go back to that plate boundary map real quick, because the question might be like, why are there even volcanoes in this region? And from what I read, basically this was the precursor to the Reykjanes Peninsula. So before the Reykjanes Peninsula had formed with all its young volcanic activity, the plate boundary actually was up here. So the plate boundary ran through the Snæfellsnes Peninsula, and then probably linked into these over here. But then because of the way the plates were moving and shifting, the boundary actually, quote unquote, jumped or migrated or moved down to this area. So this is the abandoned former plate boundary that connected to the ridge out here. The question now would be like, well, why is it still, why is it still producing magma? And for that, I don't really know. Is it residual magma in the system? Is there enough extension still going on there that triggers that? All really good questions. Is it somehow like a plume leading from the hotspot? All really good questions there. So anyway, I just think that this is a pretty interesting little system, and we'll just kind of have to see going forward if anything happens with it. My best guess is, we might continue to see earthquakes. The chances of this thing escalating into an eruption right now, I'd say, are pretty low, but not zero. And so it does warrant some attention and continual monitoring, but not at the expense of watching some of these bigger volcanoes out here. Okay, I think that's all I have for you. Hopefully that was a good 45 minutes or so of me droning on about geology things. Hopefully that was helpful to you as well. I tried to give you some information I thought was interesting. It's fun to learn together. So it's been interesting for me. I have a pretty good handle, I feel like, on the Reykjanes Peninsula and a little bit on some of the other volcanoes in Iceland, but this was not on my radar. And I actually have been out along the Snæfellsnes Peninsula. It's beautiful landscape, great geology, but I don't know much about this area. So I'm excited to learn more moving forward. So how are we looking? How are things looking over here on the live chat? Great. Looks like there's some questions that are coming in. So if Amanda Joe wants to send me the first round of questions, I can try and answer those as best I can. And we'll go ahead and switch over to the viewer question and answer. So something about Ethiopia, Iceland. Certainly with Ethiopia, like big picture stuff, I'm pretty well versed. I wouldn't say I'm an expert by any means, but East African Rift, I've actually spent some of my research down in Baja California looking at rift systems and structures related to that. So yeah, if you could send me those questions when you get a chance, Amanda Joe, we'll switch over to the question and answer period. Let me grab a quick drink before we get going. Hopefully everyone's doing all right. Meg loves her cozy sweatshirt. Awesome. Yeah, good stuff. I was really, that's the main thing, is I wanted to make sure that if I'm going to put my name on an article of clothing and people are going to buy it, I didn't want it to be, lousy quality. We've all bought, right, a shirt that was too stiff, or, as soon as you get it, you're like, oh, bummer. And then there's the shirts that you just wear all the time till there's, threadbare because you just love them so much. They're so comfortable. Okay. Good stuff. J. Scott McLean says I'm still 5x5. I'm just stalling till I get that set of questions, and then we'll go from there. All right. Oh boy, lots of questions. Yeah, so there was one question about the LA fires and how the topography affected that. Let's maybe start with that, because I think I have a little bit I might be able to share that is of interest to you there. And it is kind of a big current event currently, at least in the US. I don't know how much attention it's getting worldwide, but so as many of you know, there's some really terrible fires that have been going on for a few days in the LA basin. Let's take the roads off. And I don't want to get into like the fire or, why isn't there water there, any of the political stuff. None of that's going to happen here. Michelle's question is a good one. So this is from Michelle Jakosik. How does the topography of LA affect the formation of wildfires? Santa Ana winds are what start the fires. Does the topography affect how the fires spread? Can it slowly spread down or speed it up? Yeah, so there is a cool little geology connection to what's taking place here. And wildfires in the Los Angeles basin are nothing new. They are typically more common in the summer and the fall. So it is a little odd that we're getting this you know, in the throes of winter, but they really can happen anytime. So I suppose to keep this somewhat short, I don't want to make this too long of an answer, but basically our topography here, and I've done a video on this when I was down at the Salton Sea, our topography here is largely dictated by the plate boundary. The San Andreas Fault comes right up through here and runs across this way, but it actually starts turning a little bit more northward. But there's a little bend in the San Andreas Fault system right here around the LA Basin area that causes a little bit of compression. So even though it's mostly a strike slip or horizontal back and forth kind of motion fault or plate boundary, there's a little bit of compression, and that compression is what's produced these mountains here. So these east-west trending mountains here north of Pasadena are actually pretty high. There are some of these mountains go over 10,000 feet. Here's Mount San Antonio, which is, you can see the snow on it here with this image, and that's over 10,000 feet. So this is a formidable, I mean, formidable maybe isn't the right word, but it is a pretty high topographic region here. On the north side of it, you have the Mojave Desert, and it's actually, you know, compared to the LA Basin, it sits at a higher elevation. It's around 3,000 or so feet. And so what can happen is when the weather sets up such that you have, everyone's heard of, I think, pressure when it comes to weather. So if we have high pressure sitting over the Great Basin, right? It could be right over the Mojave. It might be up here near Vegas. But if we have high pressure in this region, atmospheric pressure, and lower pressure off the coast, a fundamental rule of air is it always moves from high to low pressure, always. So what makes the wind blow would be a fun question to ask at your next social event. And there's some funny answers I could give about that, but I won't. The wind blows because air is moving from high to low pressure. That's why a hurricane is drawing the air in from adjacent areas, and that's why hurricanes can grow to be such a strong storm system, as they're like vacuum cleaners. They're sucking the air in towards them. So when we have higher atmospheric pressure over this desert region here and low pressure here, and if those pressure differences are greater, the air is going to want to get there quicker and the wind speeds are going to be higher. So the air is moving, it's offshore winds, right? It's not like we typically think of the, you know, onshore winds, like wind coming from the ocean and blowing inland, but you can actually get, depending on how the weather sets up, wind coming from the desert and moving down towards the coastline. Now, as that air moves over the topography, you know, it's forced to come through these canyons, and so it's descending. The air is going from higher elevation. It goes up over these mountains, which we've seen are quite large, but then it comes racing down like some of these canyons here, and as air moves from higher elevation to lower elevation, it gets compressed, and by compressing air, it makes it hotter. So the air, and it gets drier. So the air that's moving downhill from the mountains towards the coastline becomes hot. It's dry. As it moves through the narrow canyons, it accelerates because it's moving through a smaller gap. It's just like you putting your thumb over your hose to make the water squirt out at a higher velocity. And so it just takes something to ignite the fire, right? The wind doesn't necessarily start the fire, but it definitely spreads the fire. So whether it's man-made or some natural cause, it can cause what would normally be maybe a localized little fire that can be put out quite quickly to really spread. And so the area that's really being hit hard, and I haven't paid a ton of attention to this, but like the Pacific Palisades area, this sort of north, I guess, west area around the LA Basin up by Santa Monica. This is, and I think there's other areas hit hard too. I think one of my viewers, they had fires up here near Pasadena and Altadena. And so it's probably more than one place, but that's essentially why we're seeing fires here. The topography is a result of the plate tectonic activity, San Andreas Fault, the compression, the mountains here, higher elevation up here in this high desert, and the coast obviously at sea level. And so these, and then the specific weather conditions where we've got a lower pressure, atmospheric pressure out here in the Pacific Ocean, higher pressure here in the interior has caused these fires to really get worse. So hopefully that was a pretty good explanation, and thanks for asking that question. I think it was Michelle. So thanks for that, Michelle. Okay, moving on to our first question on the sheet. Thanks for sending these, Amanda Joe. Let's see. Okay, so general questions from Jeffrey Porter. Why do faults become inactive and they become active again? Well, faults, it's a really good question. It kind of goes along with volcanoes. Like how do we define an active volcano versus an inactive volcano? How do we define an active fault versus an inactive fault? How much time needs to go by without any activity for us to officially call it inactive and label it as such? And these are all difficult questions that scientists have had to deal with and answer. With regards to faults, I think it's something like, don't quote me on this, but the USGS usually, so there's a couple ways to do this. Clearly, if the fault has produced a historic earthquake, like the 1983 Bora Peak earthquake, the 1971 Fort Tejon earthquake, if I'm getting those dates and places right, then it's still considered active. It's fairly recent, in human history, and the fault could produce earthquakes again. Remember, faults don't move like conveyor belt style. They get locked. There's friction across the rocks there, but they build up stress. They build up tectonic stresses. There's a lot of friction along that interface, and then eventually the stress exceeds the strength of the rock, and the rock breaks, it slips and moves, and that's what generates an earthquake. And so I guess the Fort Tejon one was 1871. I think I got that right. Yeah, so I think the USGS, I think it has to be, someone can look this up. Someone probably knows if I look at the chat. I think active faults according to the USGS, are faults that have produced an earthquake within the last, is it 1,000 years? It might be something like that. When it comes to volcanoes are a little trickier because like Yellowstone hasn't had an eruption in 70,000 years, and it hasn't had a big eruption in 640,000 years, and so that's a lot of time, but yet it still shows signs of activity. And so it's tricky to put labels on things. But for faults, and the other thing we use for faults is looking at the surface. Like you can clearly see here the active trace of the San Andreas on the topography, and there's places along the San Andreas where you can see it offsetting streams, or if it was a normal fault, up and down fault, you might see a fault scarp, a little escarpment, a little cliff face there. So if we have landform features associated with that fault that suggest it has moved more recently, might still be thousands of years old, those are still considered active faults as well, the way I understand it. But so it's a bit messy, and so I probably didn't give you a nice clear-cut answer, but that's what I can say there. From Steffi Adcock, I think seismic waves can tell something about the density of rock it travels through, so I wonder if any earthquake data could give a clue as to the magma composition. Just a thought. That's a good thought there. I don't know for sure, but I don't think the seismic behavior as it moves through magma in the subsurface, I don't think it tells you much about the composition. I don't think there's enough of a difference in the magma compositions to see. It can tell you a little bit about how crystalline it is. So this is very hot, more liquidy magma versus this is more slushy or has crystals in it. Yeah, that's all I know about that. That'd be a good when we circle back, and hopefully we'll do another interview soon with Mike Poland of the Yellowstone Observatory. That'd be a great question for him. So let's put a pin in that one. Sounds like Amanda Jo answered a lot of your questions on the chat. That's awesome. But a couple that she sent to me, Jim Sadler, with regards to Ethiopia, could it be a slow effusion, hypabyssal or silicic magma, or something bigger? I think everything I'm seeing coming from Ethiopia, the most likely scenario is it's basaltic, it's the same kind of magma or lava that we saw erupt in Iceland. But there is the chance it could be a more silica-rich type of material. And it could be hypabyssal, so that fancy word used there means that it's a shallow intrusion. I mean, it really already is hypabyssal in that it's a shallow intrusion. But yeah, is it silicic magma? I don't think there's any evidence for that yet. I think gases and the earthquake patterns might reveal some of that as well. But I mean, if you look around this, yeah, sure, there's one more silica-rich volcano, and that's worth noting. But if you look at the number of vents on here that are basaltic, it appears that that dominates the system, that basalt eruptions are much more likely than anything else. And so that would be sort of my default until I received other information to the contrary. From João Pedro Tavaria, how magmatic intrusion can impact atmospheric temperature and seawater temperatures? Heat transfer noticeable? Yeah, so when we have, well, you'd have to have the if it's a magmatic intrusion, it's going to have no impact on the atmospheric temperature. So if you're walking around here in Ethiopia and it's a 25 degrees Celsius day or whatever it is, the fact that there's heat below you would have no effect on the atmospheric or the ambient air temperature, because rock is a really good insulator. So even if that magma body was half a kilometer below your feet, you would really have no way of knowing it. There would be no transfer of heat from that subsurface magma body up into the atmosphere. For seawater temperature, same sort of thing. Like, you know, you go out in the ocean and look at the same sort of thing. Rock's just a really good insulator. From Vivid Magic, as all continents were together as one whole land connected long ago and were spread and combined again, the last time was named Pangaea, I believe. Are the continents spreading more now? I don't think there's any evidence that suggests the continents are spreading more than they have in the past. You know, there's these simple things called Wilson cycles where continents move apart, ocean basins are created, but ocean basins can only become so large. Their ocean crust, that old ocean crust that's connected to the continent, becomes decoupled. It starts to sink. That creates a subduction zone, and once you create a subduction zone, it closes the ocean and it smashes the continents back together. So I don't think there's any more spreading now taking place than there has been in the past. One more question on Ethiopia from Wendison Cherene. In Ethiopia, most of the previous steam will now stop ejecting steam. Why? I guess talking about the video I showed. Eventually, I mean, if you've got a pocket of heated groundwater or gas, think about like a geyser eruption, right? Like it doesn't last. It expels that hot water and gas for a period of time, and then it stops, and then it recharges the system, and then it does it again. And that might be what we're seeing in Ethiopia with that type of behavior, if I'm reading your question right. Okay, questions on Iceland that have come in from Tim Pointing. Hi, Tim. Let's see. Can you give us insights into possible causes of the stair-step inflation at Svartsengi? Seems to be almost periodic, 9 to 14 days. Yeah, I think I kind of addressed that. If you look at, I guess he's looking at this behavior here, that it is a bit step-like, right? Like it's ramped up the last few days, but prior to that, excuse me, it was a bit of a flatter trend, and then there was a slope, and then there was kind of a flat section. And I think it's mainly related to, I would assume it's like magma input. Excuse me, I think it's just the magma is ascending into this shallow storage zone, but not at a constant rate. And so if it's not coming in at a constant rate, excuse me, then you're not getting the ground uplift occurring at a linear rate. And so we get these kind of, it ebbs and flows a little bit. That would be my take on that. From Jim Sadler, from the petrology, are the current magmas mostly rift, morb, or their Iceland plume contributions? I think most of the magmas that we see coming out with the eruptions on the Reykjanes Peninsula, I think they've mostly been decompression melting related, not. And I remember now asking Professor Thordarson about this. They don't seem to have a hot spot or plume contribution, maybe minimal, but it's mostly the plate boundary, the divergent plate boundary. From J. Bant Sexton IV, Professor Willsey, I know you're a busy guy, but any plans for a deep dive my Iceland erupts mafic, intermediate, and felsic magmas. I've also read their economic minerals more so than some hotspots. Yeah, I don't know much about the economic minerals. I don't have anything really to share there. Obviously, when you have these magmatic systems, you have different rock types and heat, then you can concentrate economic minerals with various processes. That's like typical ore geology. As to why we have, yeah, and I don't want to do a deep dive on it here because that would be like a 40-minute lecture probably, but the reason we have different magma types in Iceland is fractionation of the magma. So as the magma comes up, the primary magma coming up from the deeper sources is basaltic, but as it sits in these storage chambers for periods of time and partially and cools a little bit, if it then gets re-injected by more material, remember that all the minerals in these rocks in basalt, let's say, they all have slightly different crystallization and melting temperatures. So basically by taking a magma body, heating it, cooling it, heating it, cooling it, allowing it to crystallize a little bit, and then heating it up again, by doing that iteratively, you can eventually separate a portion of that magma out that's a little different composition. You gradually change the composition from purely basaltic into the more silica-rich phases, and that's why we have these central volcanoes in Iceland that behave much more explosively, that create big, stratovolcanoes like Katla down here. They're capped with ice. And so that's the reason there. There is one paper I read too, or study, and I don't remember all the details, but there is some controversy and or suggestions that parts of Iceland might have some residual continental crust attached to it. So if that magma is coming up through continental crust, which is granite, then you can change the composition of your magmas to more silica-rich ones. And that's what's happening in a lot of different places too, like Yellowstone, for example. From John Weiss, is the Mid-Atlantic Ridge moving from the west volcanic zone to the east, or was it on the east and jumped to the west? Okay. Oh, and then he's got a map that we can look at to see these, perhaps. Let's see, is that... let's see if I can open up this map. No, that's not right. Well, let's just use the one I had. Hopefully that's okay. Where is my map? This one. It's moving to the east one, basically. So the idea is that it moved from the Snæfellsnes Peninsula to the Reykjanes, and eventually the Reykjanes is going to be abandoned, and it's going to move down to where the Vestman Islands are here in Heimaey. So this will become the new sort of connection point. So there's sort of a southeastward, I guess, sort of migration, but it's going to take some time. I mean, the Reykjanes is pretty young. It could erupt still for thousands, maybe a few millions of years. I think the Snæfellsnes one was 7 million years old. That's when it was part of the active plate boundary system. 7 million years maybe, and it went a little bit beyond that up to some point, and then it jumped down to this one. It's going to jump down to this one. But I think, if I remember right, that it's switching over to this one. I think this is going to become the more, so I think it's going from the western to the eastern, if I remember right. Good question. Yeah. So I think I got through that page of questions. Is there another page, or how are we doing? Let me circle back to the chat here. How's everyone doing? Hopefully those answers made sense. And I appreciate you guys, this question and answer thing does not necessarily always have to be me, top down kind of thing. Manda Joe can answer questions. Susan can answer questions. You guys can answer questions amongst each other. We're all like at different points in our learning spectrum. Let's see here. Oh, I think maybe Amanda Jo answered that one. Yeah, she did. Okay, I saw Mike Wright's question about the quakes, AM, MLW. She's got that. Yeah, the ones that have been, the system just sees the earthquake and throws it up there on the date with the data, and then there's ones that actually been reviewed and looked at. Because there's lots of things that can mimic seismic activity. It could be construction, mining, or something like that. Sometimes even severe weather. And so they have to go in and make sure they separate out the legit quakes from the not so legit quakes. So, yeah, is there another round of questions? If there is, you can go ahead and send that one through. And if not, we can wrap this up here in the next few minutes. Hopefully folks are doing well. This has been good and productive. I guess I can talk real quick while we're seeing if more questions are going to come in about what the rest of kind of the spring looks like. And that, of course, the Iceland potential eruption in Iceland, we've talked about the Met Office update there, and they're thinking, well, yeah, it could be, late January or early February. And wouldn't you know it, that coincides with a time when I'll be gone. I'll have some folks over in Hawaii. Hopefully we'll get to see something there. So if there is something that takes place while I'm gone, I'll just do my best to kind of keep you up to date as best I can. We'll just kind of have to see how that goes moving forward. And then let's see what else. Oh, here we go. A couple more questions just came in. Okay, one more question here, I think. Two more. From Annette Filtenborg Hansen. Is the Icelandic plume not rooted under Greenland with the tilt to Iceland? No, I think it is. I think they've done some seismic tomography, and now I got to try to remember that. I just read that paper not that long ago. I think you're right. I think that the plume comes up from very deep, hundreds of kilometers down, and it's at that point it's more under Greenland, but then it does have a bit of a tilt to it, and it doesn't have to take much of a difference, right? If you have a small angle over a big distance, that could be a big difference in distance here. And Greenland's not that far away from Iceland, as the crow flies in that respect. So I think you are correct on that with your question. From Lessenath, how much of the more evolved magma in Iceland is fractional differentiation as opposed to remelting? Oh boy. I think it's mostly fractional differentiation. So when we say evolved magmas, we're talking about primitive magmas would be things like basalts, more mafic, hot fluid ones, and as they contain more silica, we call those more evolved magmas. So I think most of the evolved magmas in Iceland, from what I've read, are due mainly to fractional differentiation, which is the process I talked about heating up the magma, cooling it off, and separating out those more silica-rich elements and minerals, and eventually ending up with a more silica-rich magma composition. I think remelting would be like less than 10% if I had to put a number on it. So not quite sure there, but those are some ballpark guesses. You guys had some deep questions today. Wow, I'm gonna have to I have to up my game a little bit here. So, but yeah, moving forward, the semester starts here in a week or two, on the 21st, I guess. And so that's going to keep me a little bit busy, but I've got some other videos coming your way. I'm going to continue to do the more of the 101 series. I'm still chipping away at those. I still have a random road cut video to get out. And even though it's chilly here, I think the weather's still good. I can get outside and do some videos. I am going to be in Tucson in February to go to the Rock and Gem show and also do some videos and some outdoor recreation in that area. Like I said, I'll be in Hawaii a little bit. And then in March for spring break, I think we're down in southern Utah, northern Arizona with some friends. So I'll try to do some videos down in that area as well. Oh wait, one more set of questions. Okay. From Uranium 235, what is driving the migration? So if the plate boundary in the south of Iceland is migrating southeastward, what about in the north? It looks like you could once have drawn a line nearly straight from the peninsula to the north. I don't know if I totally get that question, but the migration of the plate boundary has to do with the fact that the two plates that are separating are not moving at the same rate, that there's sections and segments that are moving apart at slightly different rates. And the hotspot is another thing in there that kind of complicates this a little bit. And so the plate boundary will tend to jump to where the hotspot is. That's why I said when we looked at this that it's jumping from the west volcanic zone to the east volcanic zone, because the hotspot's pretty much here where the dashed line is. So because the hotspot's generating hotter rock and therefore weaker rock, the plate boundary will tend to exploit that, especially when the dynamics and the vectors, the forces line up. And that's probably a terrible explanation, but kind of a quick and dirty one. Yep. And then Charles W53, have you tried to interview an astrogeologist such as Mars Guy? No, I'm going to keep doing the interview series. There's a lot of different people I want to get to. I'm not familiar with the Astro Guy. I definitely want to start getting geologists and scientists from different backgrounds and career paths. The new one that just came out recently, I know some of these interview ones are long, so as you look at the time on them, you're like, oh my gosh, it's 90 minutes. Do I really have time for this? But you can chip away at it. I'd encourage you to listen to some of those and watch them. I mean, really, they're the type of video you could just put on and listen to, because there's sometimes a little bit of graphics, but mostly it's the two talking heads talking. But the recent one with Simeon Kasky was really interesting, his path and some of the work he does with Grand Teton National Park. I found that just really interesting. I guess Sky Cooley was before that, and that was fascinating. So I'm having a ton of fun doing them and learning about other people and how, our common denominator is geology, but it comes in so many forms and guises that it's been a real kick to me to do those. I know those videos aren't maybe the most exciting and lucrative, but give a couple of them a watch or a listen and see if you enjoy those, because I think there's a lot we could all learn from. I think people's stories are just interesting to me. Like, how did you get to do this? Like, how did you end up in this position? Like, what was the crazy quirk of the cosmos and the circumstances that led you from point A, as a high school student or whatever, to this point here? And sometimes it's a real direct linear path and you can kind of see the whole way forward, and other times it's convoluted with serendipity and all sorts of things that come into play. And so I've just found that really interesting and fascinating. So I'm going to continue to find people, but I do appreciate the suggestions. It's the list is going to be long, and I'll never obviously run out of interesting people to talk to and to learn more about. So pretty fun stuff there with the interview series. And so you can find those real quick if you're so inclined. Those are playlists, and then you can go into interview series. And so there's the most recent one with Simeon. I've talked to other YouTube geology folks. Mike Poland's just a wealth of information, and so I think we'll do more stuff with him. But mostly I've been doing these like government people. Skies was interesting because he's had so many different worked under so many different kind of umbrellas and such. So I'm trying to find more like people in the oil and gas industry and people in doing mining or environmental consulting. And so I just need to kind of work on getting some of those done as well. But yeah, you can expect more of the same, I suppose, from me. Anything else? I think that's about it. And I think we want to wrap up here in a few minutes. We'll continue to watch these things as we go forward, team. Kilauea, still watching things in Kilauea. Appreciate all your support. Appreciate everything you do here to help support the channel. Especially want to give a shout out to Amanda, Joe, and Susan for helping out as well. And we're just having a good time here, learning together. So I think with all that being said, and lunch sounding like a good idea, I'm going to sign off now, and we'll do maybe another live stream, maybe in a month or so, maybe in 3 weeks, something like that. Certainly if something big happens, I'll be sure to circle back and let you guys know. But happy birthday to Sandrine if you're still with us. All our good friends there in Europe, thanks for staying up a little bit later. And we'll see you next time, team. Thanks so much for joining us, and have a good one. Take care.